Hey everyone, welcome. This is 6.3. It is called Solving Systems with Inverses. Alright, so what we're going to do is we're going to consider this following scenario. Three friends, Dwayne, Marcia, and Parker, decide to take their younger siblings to the movies. Before the movie, they buy some snacks at the concession stand. Dwayne buys 2 candy bars, a small drink, and 2 boxes of chocolate-covered peanuts for a total of $11.85. Marcia spends $9 on a candy bar, 2 small drinks, and 1 box of chocolate-covered peanuts. Parker spends $12.35 on 2 small drinks, 3 boxes of chocolate-covered peanuts, but doesn't buy any candy bars. If all the prices include tax, what was the price of each item? Normally what we'd have done is you would have set up a system of equations with all that stuff, and it would have looked like this. Alright, so the top one is Dwayne, Marcia, Parker. And then what you have to do is get one variable eliminated, so you have 2 variables, and then from those 2 you get 1 variable, and then solve for P, and then bring that in to solve it for D, and then bring that back in to solve for C, and then you'd be done. That's a lot of work, and I tell you what, there is a shortcut, and it's called matrices. They are going to be really, really helpful. So what we're going to be learning is a way to solve this problem without having to do a page of work, because it usually takes like a page to do all that stuff. Alright, so here is an example of what we're going to be able to do to kind of bring this a better way of kind of understanding how matrices work. So we got y equals 5x, and it says I want to solve for x. So normally what a lot of you do is, let's say, divide by 5, and you'd be absolutely right. But what we are going to do now is we are going to, instead of divide by 5, there's a different way, and it's going to be multiply by 1/5. Multiply by 1/5. So we'd have 1/5 y equals, and I'm just going to put the 1/5 times 5x. Now if I take 1/5 and multiply it by 5, what happens? They cancel out and they equal 1, so we get 1x equals 1/5 y. Now you can leave it like that. You could also write it as y over 5. It's kind of interchangeable, and I kept that 1 there because 1 times x is going to be just x. Now normally we just kind of forget about that 1, but it's important for what we're doing here, the identity matrix. Now we're going to be doing kind of the same stuff, but with matrices. So the identity matrix is the matrix equivalent of multiplying by 1. Okay, so that means if I take some number, some matrix x, multiply it by 1, I will end up with just itself, which is the identity property of multiplication using algebra. So it's nothing new, it just also applies to matrices. Alright, and 1/5 and 5, 1/5 times 5, we know that those two are inverses of each other. So the same process is going to hold 1/5 times 5 equals 1. Is going to hold for inverse matrices. A matrix and its inverse matrix multiplied together are going to end up becoming the identity matrix. All right, we'll get into definitions of that stuff in a little bit, but I want to give you this example first. All right, so here is the example. It says find the identity matrix for the matrix 2, 1, 4, 3. It's not 21, 43. It's 2, 1, 4, 3. So the first thing we have to know is that we're going to take 2, 1, 4, 3. Okay, I'm going to take this matrix, and I'm going to multiply it by something. We don't know what that something is, so we're going to call it A, B, C, D. We don't know what each letter represents, what number it represents, so we're just going to keep them all as variables, A, B, C, and D. Okay, and what should happen when we multiply those together is if I'm taking some number, multiplying it by an identity matrix, I should end up with the original matrix that I had, 2, 1, 4, 3. Alright, so what should happen here when we go through this is I'm going to do, if you remember from last section, it was row times column, right? So we're going to try and do this with all those colors, so I'm going to do 2 times A plus 1 times C. Alright, and then that is going to be good for that part. So 2 times A, 1 times C. I'm going to do the same thing again. So it's going to be 2 times B plus 1 times D. To save myself a little bit of time, we're going to try and do that. 2B plus 1D. Alright, so that'll be the top 2. And then we're going to go to the bottom. 4A plus 3C, and I'm going to do the same thing again, 4B plus 3D. So now I should be able to plug these in a little bit faster. And I've got A here, and then we're going to have C here, and then we'll have B and we will have D. All right, so that is going to be our new matrix, right? So that would be our new matrix if we multiply all those together. Now what I'm going to do is, instead of making a matrix and equal this matrix, I know that this top left one has to equal this number, right? Row 1, column 1's got to equal this one. Row 1, column 2's got to equal that one. So I'm just going to do this in a different color. All this stuff has to equal 2. All this stuff has to equal 4. All this stuff has to equal 1. All this has to equal 3. In order for that to hold, row 1 times column 1's got to be a 2. Alright, so what we're going to do is we are going to solve both of these. I should have maybe brought them out a little bit further so they wasn't so congested, but I think we'll get through it. So, I'm looking at these two, and I say, which variable do I want to get rid of? A or C? It doesn't matter. So what I'm going to do is I'm just rather multiply by -2 on the top. So I'm going to rewrite the top one. I'm just going to rewrite it. So if I multiply this whole thing by -2, multiply this by -2 also, it's going to be alright. So that whole thing is going to be -4a plus -2c equals -4. Alright, so if I cancel all that out and I just add this one and this one together, I will end up with a's cancel out. 4 plus -4 is going to be 0a, and I get a c equals 0. Okay, so the a's cancel out and c equals 0. So I can plug it back into one of these two and say, what is a going to equal if c is 0? So if c is 0, 4a plus nothing is 4. That means a has to equal 1. Alright, so we've got a equals 1 and c equals 0. So I know those two. So what I'm going to do is the same thing with this other equation. So let's try it in a different color. Let's try blue. So I'm going to multiply this equation again by, I'm going to do the same thing with b's. I'm going to multiply it by -2. So all those, that top one's going to be -2, and multiply this by -2. I'm going to write it underneath. So I've got -4b plus, and this is going to be a -2d, equals -2 times 1 is -2, and I'm going to add these together. The b's cancel out, so it's going to be 0b, that's not even going to be there, and this is going to be a 1d equals 1. So that means d equals 1. So now if I plug it back into either one equation, 2b plus 1 times 1 equals 1. That means that b has to equal 0. And now I've got my matrix. A is 1, B is 0, C is 0, D is 1. So the identity matrix that we have is 1, 0, 0, 1. Alright, which kind of makes sense because when you multiply row times column, I want to have this one multiplied by 1. I want this one multiplied by 0. So it's going to be 1 and a 0. And then when I do the second one, I want this row should end up, this row times this column should end up here. So that means I want the first one to be a 0. I want this one to be a 1. So it ends up as 0 times 2 and 1 times 1 equals 1. So 1, 0, 0, 1 is the identity matrix. Alright, so what we're going to do is now let's get that definition for identity matrix. It is right here. It is a square matrix. And when I say square matrix, that means it's got to be a 2 by 2 or a 3 by 3. As long as those numbers, the rows and columns, match up. Where you have 1 in the main diagonal. Alright, so that means if I have a 3 by 3, I'd have 1, 0, 0, 0, 1, 0, 0, 0, 1. Alright, I have 1s in this main diagonal. Alright, and 0s everywhere else. 0 everywhere else. Alright, so the formal definition, and we're going to say this is going to be the identity matrix, and it's going to be a matrix. I equals that whole thing. Alright, so if I have any matrix A, I multiply it by the identity matrix I, it's going to equal that original matrix A. And I can also do the same thing if I do I times A. It's still going to equal A. So it doesn't matter which one comes first or second. You'll still end up with the same thing. So if I switch these two around, it still get to the same matrix in the end. So it doesn't matter the order in which you multiply them. Alright, so the last thing we've got here is the inverse matrix. The inverse matrix is if we take a matrix A and I multiply it by its inverse, and we write it as a to the -1, just like that. Alright, that is going to equal the identity matrix. Alright, I'm sorry, actually we don't write it like that. The -1 goes outside the matrix. My fault. So it's a times the inverse of A is going to equal the identity. Same way that 1/5 times 5 equals 1. All right? So the original identity, the original matrix A, this one right here is the inverse matrix. And again, it's written as A to the negative 1. When they multiply together, you get 1, 0, 0, 1, or any sort of equivalent if it's a 3 by 3 or a 4 by 4 or a 5 by 5. Most of people will be dealing with 2 by 2s, maybe a few 3 by 3s. All right, to keep this short as I can, your assignment here today is to do this. Write an identity matrix that is a 2 by 2 and a 3 by 3. Good luck.